So far we've encountered two types of turning points. We've got local maximums and local minimums. And the third scenario we've come across are points of inflection. So let's just define and clarify what a point of inflection is. A point of inflection is a point where the concavity of the curve changes. So it goes from concave down to concave up, or concave up to concave down at a particular point. Another way of looking at a point of inflection, so algebraically, that if the second derivative is negative on one side and the second derivative is positive on the other side, then we have a point of inflection. So this is what we mean by concavity. The second derivative tells us about concavity. So if the second derivative changes sign through a point x equals a, then we have a point of inflection at x equals a. So let's just sort of do a little few sketches to graphically show you what's going on here. There's three different scenarios. So here, the concavity, so y double dash of x, now because it is concave up here, so if you like, the cave is opening towards the top. So when we have that scenario, the second derivative, any value of x you put in the second derivative here will be positive. And here, the cave opens down, so the second derivative of x will be less than 0. So here we have a point of inflection and what we call a horizontal point of inflection. At x equals a. So at this particular point here, because the first derivative is equal to 0, the tangent drawn at that point will be parallel to the x-axis. So the concavity here has changed. It's been positive here and then it's gone to negative here. In this case, we don't have the first derivative. The gradient of this point is infinite, so y dash is infinite, so it's not equal to 0. Here we have, once again, concave up, so y double dash of x will be greater than 0. And here y double dash of x, every point from A onwards, it is concave down, so y double dash of x will be less than 0. So with this, instead of being a horizontal point of inflection, so the tangent is parallel to the x-axis, we have a vertical. So this is a vertical POI, a vertical point of inflection at x equals a. This third scenario down here, we've got concave up before x equals a. So we have y double dash of x is greater than greater than 0, sorry. And this is concave down. So it's gone from concave up to concave down. And here y double dash of x, so the second derivative, any x value greater than a you put in, you'll find that the second derivative will be less than 0. So you have concavity down going here, this is concavity up, and here you have a point of inflection and it is called an oblique point of inflection. Alright, so three different types: horizontal, vertical point of inflection and oblique point of inflection. In each of these three different cases, the concavity around the point in question, which is x equals a, the concavity changes sign. So the concavity is obtained by finding the second derivative and just putting x values in on either side of A, so you can determine whether you get which one of these points of inflection.